Right, so last day we looked at the vector equation of a line. We looked at proving it, and we went from the vector equation of the line to the parametric equation of the line, right? How we did that, we made x, y, and z the subject of the formula. After the parametric, what was the next version? The Cartesian, right? And to get the Cartesian form, what we did? So you make lambda the subject in each one and then equate it. All right? So those are the three forms. Cartesian here with no lambda, parametric with x, y, and z in terms of lambda, and your vector equation of the form with what's A and B again? A is the what? R is the random, R is the equation, A is the point on the line, and P is the direction vector, right? All right, nice. Let's do one quickly. Write this here. Write this equation of the line, and I want you to go from here back to all the others. What is called this form again? Cartesian. So take the Cartesian, get the parametric, then get vector. All right, so you would recognize that you can make lambda equal to everything, right? Then you make x the subject, y the subject, and z the subject, right? You all got that for the Cartesian? Sorry, for the parametric? Yeah. And then to go to vector form, once you write it neatly, this is your R, this is your A, and this is your B. Right? So you'll end up with, if you write it neatly, right? Minus 1, 2, 1, that's the A. And then you have plus 3 lambda, minus 5, plus 4. That is your B. Okay, so you could write R plus minus 1, 2, 1, plus lambda by 3 minus 5, right? So those are your different forms. I just wanted to remind you what the different forms, right? The next thing we need to be able to do is we need to know if vectors are parallel. How do you know if vectors are parallel? They are what? Right, they are multiples of each other. Right? If they intersect, it means that when you solve them, you should get a solution, common solution. And if they don't intersect or they are not parallel, they are said to be skewed. So we're going to take a look at something called skewness now. All right? Before we do skewness, how do we look at how do we know parallel lines? Right? Just make a note of that. If you have two lines, line 1 and line 2, to determine if they're parallel, you have to compare their direction vectors. So you're comparing B and B. If they are multiples of each other, then they are parallel. All right? Just make a note that you have to compare the direction vectors. Take a look at L1, L2, and L3. Which ones they are parallel? So I kind of cross out, you can look at the note, I kind of cross out some parts of it, right? I kind of cross out this curve, the way you're looking at that. I want you looking at the direction vectors. So which of those direction vectors are parallel? Line 1 and? Right, yeah, because if you multiply this by 2, you will get this vector, right? If you multiply this by 4, the numbers working out except for 2. So it means that line 1 and line 2 are parallel. So our focus really is to determine if vectors intersect or not, right? And watch this here, right? This is the best I could do. If lines are parallel, vectors are equation of a line are parallel, they look like the first diagram. If they intersect, they look like the second diagram. If they are skewed, means that they are not parallel and they don't intersect. So they look like the third diagram. Two totally different planes. So you're focusing in 3 dimensions, right? Those lines will never meet. They're looking like they might intersect, but they are totally different planes. Right? And a line is something 2-dimensional. So that is not going to meet at all. Right. So we're looking at something called skewness, right? How do we show skewness? Well, in order for us to show skewness, we have to show that the vectors are not parallel and they don't intersect. All right? So I want to show you now how to determine if vectors intersect. All right? Copy down skewness. All right, just make a little sketch there. All right, so how do we show intersection? So if I give you a plane, right, and you want to determine if line 1 and line 2 intersect, then obviously they will be parallel, right? And they will have this point here in common, right? So they have a point. So this point, whatever the point is, let's call the point X, Y, Z. That point should be common to both L1 and L2. All right? So what we're going to attempt to do is to solve the equation and see if both L1 and L2 have this point in common. Right? Basically, what we're doing, we're going to get two equations, solve simultaneously. Right? And then plug it back in and say the third point is the same. So we're going to take X and Y for both of them, solve it simultaneously, and then check for Z. Okay? So let's take an example, see if it makes sense, right? Right, minus 2, 1, 5, right? Minus 3, 1, minus 5, minus 3, 2, 11, and 5 minus 1, 4. All right, so I'm going to give you an idea of the steps that we're going to take and how we're going to go about this, right? So the first step, we're going to write the lines. We're going to take L1 and L2, and we're going to put it in the easiest form to read off. We're going to put it in the parametric form, right? We're going to put it in the parametric form. After we do that, we are going to solve X and Y simultaneously to get, we're going to solve X and Y simultaneously to get these two things here, to get lambda and mu, to get lambda and mu. And then the third step, we're going to substitute lambda and mu in Z, right? For both of them. Right? We're going to substitute lambda in Z to determine if they intersect. Right? So these are the three steps that we're going to take. So the first thing I will do if I'm doing a question like this, yes, Kira, I'll watch these two. And I will check and see if they're parallel. Are they parallel? I can't multiply this by anything to get this. So they're not parallel, right? So I'm going to check and see if I can follow those steps to see if they intersect, right? Copy it, I'll make sure they're ready. Right, so step number 1, for L1, I'm going to put L1 into the parametric form. So R is X, Y, Z, so X is minus 2 minus 3 lambda. X is minus 2 minus 3 lambda. Next step, Y is equal to 1 plus 1 lambda. And Z is what? Z is 5 minus 5 lambda. Now for L2 minus 3 as mu, right? So X is equal to minus 3 plus 5 mu. Then Y is equal to 2 minus mu. And Z is equal to 11 plus 4 mu. Right, now next step. We have to solve simultaneously. If these 2 points intersect, then the X values will be equal, Y values will be equal, Z values will be equal. So all I'm going to do is I'm just going to equate. So I'm going to equate here and here. So minus 2 minus 3 lambda is minus 3 plus 5 mu. Right? And we can rearrange and work it out. Bring it across, you'll get 1 minus 3 lambda is equal to 5 mu. All right, let's check the next one out. Right, so leaving it like this. Bring it across here, I'll get 1 minus 3. Next, I'm going to equate the y's now. Right? I'm going to equate the y's. So 1 plus lambda is equal to 2 minus mu. So This is much easier to make lambda the subject, right? So lambda is equal to carry across the 1, and you'll get 1 minus mu. So I create them, x, I create the y, I solve for equation 1, equation 2. I'm going to put this in this. Right? So I'll go in and substitute equation 2 in equation 1. So that's 1 minus 3 by 1 minus mu is equal to 5 mu. So 1 minus 3 plus 3 mu is 5 mu. Bring all the mu's on this side, and you'll get 2 mu. So mu is equal to minus 1. Plug in minus 1 there, and you'll get lambda. Lambda is 2. Right, Shivish? Keep watching here. Lambda is 2. What's the last step? We found lambda, we found mu. Substitute them and see where you get to Z. So 4 L1, Z is what? Z is 5 minus 5 by lambda. So I got 5 minus 10, which is minus 5. And for L2, Z is equal to 11 plus 4 by minus 1. Oh, all right, so down bad. It's supposed to be minus 5. That won't affect anything, right? Minus 5 minus 11. Right? Minus 5 minus 11. Right? Minus 5 minus 11. So this would have been minus 15, and this would have been minus 15. If the value is not the same, it means it's not consistent and they don't intersect. Right? From my first example was supposed to intersect. So therefore, L1 and L2 intersect. Right? And we can be more specific and tell them where it intersects. The Z value is minus 15. The X value is what? We could put lambda in here or put mu in here. Put lambda here now. You'll get minus 2 minus 6 is minus 8. If you put mu in here, you'll get minus 8 too. And then put it in here. 1 plus 2 is 3. Check it here again. 2 minus minus 1 is 3. So that's the point. All right? Right? So online, in case I get lost, right? I made a mistake with the signs in the early. It's minus 5 minus 11. Right? When you solve for lambda and mu, plug it back into Z. If it get the same values for both lines, it means that it is consistent and they intersect. If the values are not the same, it means they do not intersect and they are skewed. All right, so remember, what are the steps to show skewed? Check and see if they parallel. Check and see if they intersect. Otherwise, they'll be skewed, right? If they don't intersect. Try this one here. I'm just going to help out a little bit to put it to the forms, right? Look at this, and if they intersect, find the point of intersection. So let's put it together, right? So let's start with L1. For L1, x is equal to minus 5 plus 6 lambda, minus 5 plus 6 lambda. Y, 2 minus 3 lambda. And z is minus 3 plus 9 lambda. Do the same thing for L2 one time. X is equal to minus 5 minus 2 mu. Y is equal to minus 4 plus 3 mu. And z is equal to 3 minus 5 mu. Right? Right? Then we do a little equating. It doesn't really matter which one you choose. Huh? You can equate these two and then check for consistency here. Right? It don't matter. Once you get lambda and mu, you can put it in here if you want. Right? But I will equate these two here. So I'll get minus 5 plus 6 lambda is equal to minus 5 minus 2 mu. Carry it across again, 0. So 6 lambda is minus 2 mu, or we get mu to be minus 3 lambda. Look at that. And then we're going to equate the y's. So that'll be 2 minus 3 lambda is equal to minus 4 plus 3 mu. Bring it across here, you'll get minus 4 become plus 4. 4 plus 2 is 6. Minus 3 lambda is 3 mu. Right? If you want, you can just divide everything by 3. So that'll be 2 minus lambda is mu. Okay? Then we can equate them. Right? We can substitute 1 and 2. So you'll end up with 2 minus lambda is equal to mu. Mu is minus 3 lambda. Right? Right? When you bring it across, you'll get minus 2. So I got lambda to be minus 1. Lambda is minus 1. So if lambda is minus 1, plug minus 1 in there, and you'll get mu as 3. So now we're going on checking L1. So Z is equal to what? Z is equal to minus 3 plus 9. Minus 3 plus 9 by lambda. Right? Lambda was minus 1. So that's minus 12. We're going on checking 2. 2 would be here. So that'll be 3 minus 5 by 3. Mu is 3, right? Minus 15. 3 minus 15 is minus 12. So therefore they intersect. Right? Where they intersect, we're going to determine now Z is minus 12, right? So let's find X. X is minus 5 plus 6 by lambda. What was lambda? Minus 1. So I got minus 11. And then plug in lambda here. Lambda was minus 1. 2 plus 3 is 5. Okay, so that's the way you handle questions like this, right? Let's do one more and then let's finish up with vector equation of a plane, right? Let's do this last one. Right, so the question said show it intersector. So it's supposed to intersect. Let's check it out fast. First thing first, for L1, right on y x. Right, minus 1 minus 2. Y is 1 plus alpha. And Z is minus 2 plus. Sorry, minus 2 minus 3 alpha. Then do the same thing for L2. X is equal to minus 2 plus beta. Y is equal to 1 minus beta. And Z minus 4 plus beta. Next step, equate the X and the Y. So that's minus 1 minus 2 alpha is minus 2 plus beta. So again, beta equal to 1 minus 2 alpha. Do the same thing here. 1 plus alpha is equal to 1 minus beta. 1 will cancel, so you'll get alpha is minus beta. So substitute 1 into 2. Substitute 1 into 2. So you'll get 1 minus 2 alpha is equal to minus alpha. Okay? So when you carry it here, I got alpha to be 1. Look at that. Alpha to be 1. And beta will be minus 1. So for L1, you can find Z. Right? That will be minus 2 minus 3. Alpha is 1, right? Minus 2 minus 3 is minus 5. And for L2, plug in minus 1 here. Minus 1 minus 5. Right? Therefore, consistent, so they intersect. So they want the point of intersection. Right? This will be the point. Z is minus 5. Solve for X. Plug in 1 here. Minus 1 minus 2 is minus 3. Plug in 1 here. 1 plus 1 is 2. Look it up. So these lines are not skewed. These lines intersect. All right? Remember, if they don't intersect and they don't parallel, they are skewed. Last thing, vector equation of a plane. So just to build up on what we were doing, right? When we started vectors, we looked at vector equation of a point in 3 dimensions. Then we looked at a collection of points, and that gave us a line. Now we're looking at a collection of lines, which give us a plane, right? So we're trying to get the vector equation of a plane. So just like everything else, if we have a plane and you want to get the equation of the plane, we need a point on the plane and something that gives us direction. So we get a point on the plane and we get it something perpendicular to the plane. All right? How do we get the vector equation of the plane? Real simple proof. All right? If we have a plane and we have a perpendicular vector to the plane called n, if we have a point on the plane called A and some random point called R, we could use those pieces of information to get the equation of the plane. First thing first, we can draw A and R back to the origin. And we can find AR. AR is A to O plus OR. From a diagram, you can see that AO is minus A and OR is small r. All right? So now here's what we know. If we know a vector on the plane, that's a vector on the plane, right? AR. And we know that that vector is perpendicular to n. What we know about perpendicular vectors are Tivish, right? If vectors are perpendicular, then we know that its dot product is 0. All right? That's it. Just multiply AR by n, and you'll see that here. Make it equal to 0, and you're good to go. Right? AR is minus A plus R by n. Multiply it out, and you get this equation here. Right? That equation is the vector equation of a plane. Right? Just do me a favor, write down vector equation of the plane is Rn is equal to An. This is also called the scalar product form. Right? And of course, we can take the vector equation of the plane and turn it into Cartesian. Right? This might look confusing, but it's just the variables, right? I'll show you with numbers how easy it is, right? So if you multiply x, y, z, which is r, by whatever n is, and then you multiply a by n, what you will get is something looking like this, and you'll get some scalar value here. This is called a scalar product or a dot product, right? And you will get something looking like this. All right? Watch a small example here. If I give you a point on the plane, 2 and 3, and it's perpendicular, this is your A, and this is your N. You want to find the equation of the plane, right? All you're doing is you're multiplying R by N, A by N, and you end up with something looking like this. This here is the vector equation of the plane. To convert it to Cartesian, just multiply x, y, z by that, and that's it. All right. So watch it again in case you get confused. This here is A. This here is N. We're going to do A and N, Shivish. Very good, Shivish. Put it in this formula here. Multiply A by N and you will get 13. And then multiply R by this point and you will get the vector equation of the plane. If you want to go from vector equation to Cartesian, multiply R, which is x, y, z, by this point here, which is 3 minus 2, 3, equal to B. Okay, so I'm just going to give you one to try. Right, find the equation of the plane there. Actually, let's get the Cartesian one time. But R is the variable. N is which one? Right? N is the perpendicular vector, and A is what? Point. R by N is here. That's 2, 4, 5. All right, 40. That's the vector. I want the Cartesian one time. What do I do to get it Cartesian? So the vector is r by 2, 4, 5 is 14. What do I do? So you put r as x, y, z. Right? Multiply 2 by x, 4 by y, 5 by z. Make it equal to 14. That's it. You're done.